Okay, I'm going to solve a word problem with using a derivative. So I picked example of worldly famous Formula One in Grandstand. I don't know if it's in Spain or Italy. That's the picture from there. Okay, so what are the key conditions, key worries for designers when they design this Formula One grandstand? First thing, they have to worry that there is enough sufficient. Here it is sufficient grandstand space that is available around the track to accommodate these viewers. The other one is safety, because car racing is a dangerous and safety consideration are paramount. Why? Because the grandstand must be placed where spectators will not be in danger if the driver lose control completely, or lose control of the car. So what are the cases here? If a driver does not slow down enough before entering the turn, the car may slide off the racetrack. Right? Right. Normally, this just results in a wider turn which slows down the driver. But this is most important thing. If the driver loses control completely, the car may fly off the track entirely on a path tangent to the curve of the racetrack. So here on the graph, we have the racetrack graph, and the model of track is y is equal x cubed plus 3x squared plus x, and this is our graph. So our problem is, so this is the dangerous curve, right? It's right here, dangerous curve, and the coordinate of these curves are of this curve is negative 1.9, and here it's going to be 2. I think it's 2.8. It just doesn't match completely, or they're considering it will fly off. That's what they are thinking. 2.8 up to 2.8, it's safe to move away from the turning point. So this is 2.8, a little bit above. Okay, so that's what it is. Okay, so we are going to figure it out. What speed, instantaneous speed, acceleration, how to calculate to figure out if it's gonna fly, at what speed it's gonna fly off, or at what speed it's gonna safely turn the curve to the right, okay, instead of flying to the moon. Right? Okay. All right. So before I would move on, I would like to explain some basic difference. Okay. So let me read the question number 1. That physicians have determined that drivers are most likely to lose control of their car as they have coming into a turn at the point where slope of the tangent line is 1. Okay, that's the most dangerous part. So find the xy coordinate of this point near the turn. Why? Well, what's the reason why they decided that's the most dangerous interval before they get into turn where slope is equal 1? First of all, here is on the graph of science, slope is at the point where it's 0. Those are slope equal 1. Okay, this one and this one. So where it's hitting the 0, it's practically 1 what was the terminology? Yes, inflection point. This is inflection point. Why? Because it's under, it goes, the line is goes under 45 degrees at the point where on x it's 0, right? Why is it going under 45 degrees? Because here is sine 45 over cosine 45 is equal 1. Sine 45 is square root 2 over 2. Cosine 45, it's a square root 2 over 2. Or tangent for 45, right, is 1. That is the reason. So these graphs, so those are tangent lines. So this is, it's going to be, this one is, we get y is equal x, right? This one, correct? Because it's going through 0 and at the going under, right, 45 degrees. This one is y is equal x plus 2 here. This one is y is equal x plus 5. And this one is y is equal x minus 2. Now all of them are running under 45 degrees. Look, they are parallel. Y is equal x, it's already 45 degrees. Why? Because when x is 1, y is 1, x is 2, y is 2, x is 3, y is 3, right? And the other ones are running parallel, which means 45 degrees. What's the danger physicians see in the slope that is of the tangent line that is equal 1? First of all, because it's 45 and 45, it can throw the car either direction, 50-50 chance. And mathematically, to explain, a slope of 1 means that if the function is plotted on the graph, then the line is rising 1 unit for every 1 unit further to the right it goes. Okay? One more time. So slope, if it's 1, that means 1 over 1, right? This one is rise. This one is run. So the line will rise 1 unit for every 1 unit movement further to the right. Okay? So, and practically the rise is changing just as fast as the movement, and that is very dangerous. Okay, so now we understood. Once we understood, I can move to solving, and we are going to explore the coordinate. Find the xy coordinate at what point it's going to be this or that car when it approaches to the turning point, meaning approaches to the slope is equal 1. This point, see? Approaches the inflection point when it's equal 1. Because it's going to go right here. It's going to come here and turn, do sharp turn, okay? So we need to explore the points around that slope. All right, so the model of this the racetrack is f of x is equal x cubed plus 3x squared and plus x. Now, we are going to take derivative and not rate of change. Why? Because we want instant speed at this point, right? Not the average, but instant. Average, we would use rate of change. Instant speed, we need to use our derivative. This is gonna be equal 3x squared plus 6x and plus 1. Okay, so since our tangent line is equal 1, I'm going to write down, because tangent line slope, it's our derivative, correct? So I'm going to write down 3x squared plus 6x plus 1 is equal 1. Okay, I'm canceling and I'm getting The solution is the easiest part. The understanding is the more difficult part because you need to understand so you can use the proper operation. So 3x squared plus 6x is equal 0, and 3x is 3x times x plus 2 equals 0, and we get 3x is equal 0, x plus 2 is equal 0, x is equal 0 accordingly, and x is equal negative 2. Okay, so 0 in this case doesn't count because here it is at this point, right? In our case, we need negative 2 because negative 2, look here, negative 2 is the one that's nearby of 1 and 9, see? This is what we are interested. 0 is here. We need to explore this turn here, correct? The point, because turning point is negative 1.9 and negative 2 is the one that is getting very close to negative 1 over 9. That's why we are going to drop 0 and explore x is equal negative 2. Okay, so let's find out how much it's going to be y. F of negative 2 is equal x cubed plus x squared, 3x squared plus 1. Plus x. Okay, so from here, this is equal negative 2 cubed plus 3 times negative 2 squared, right? Why I don't plug this negative 2 in the derivative? Because I need the function. I'm going to go by the path of driving function, right? Okay. 3 times negative 2. In the previous case, previously I used derivative because I had slope, right? So, okay, 3 times negative 2 cubed oh no, 3 times negative 2 squared and plus x, which is minus 2. Okay, let me clean this and just put minus 2. All right, so from here, we are getting f of minus 2 is equal negative 8 plus 12 minus 2. And we have here 2. So what does that mean? That the xy point, here we have, find the xy coordinate of this point near the turn. So since our turn is around, it's negative 1.9, right? And how much is it? 2.8. So near a point, x of y is going to be negative 2 and positive 2. Let me change the color and I put, no, okay, too thick. Okay, so the nearest point is this one. It's going to be safe to turn from this point, from this coordinate. Next one, as you can see, everything includes math. Without math, we don't have life. That is very true. Okay, moving to question number 2. Find the equation of the tangent line to the curve at this point. So at the point, so what is, now since we know it's safe to turn it starting from this coordinate, we need to know what tangent line will go through this point. We need to find the equation, line of equation of the tangent line. Okay, so slope and intercept, remember? Y is equal mx plus b, right? Well, I'm plugging y is 2 is equal, slope is 1, right? We know slope is 1, and coordinate of x is negative 2, right? Let me write down here, our m we know is 1, and point is negative 2 and positive 2, right? From the previous calculation. and we have plus here b. We need to find b so we can write down the equation. Remember how to find equation based on slope and 1 point. Refresh your memory in the algebra. If not, open the graphing playlist and you definitely will find there how to graph. Okay, so and b from here is equal 4, and practically we are getting y is equal x plus 4. Okay, let's solution change to this working color, and with this light brown color I will use the answer. So y is equal x plus 4. Let me write down. Okay, here also I'll add answer. All right, said that. Moving to question number 3. Well, I hope it's interesting because this problem is really interesting, at least to me. So hopefully it's interesting to you also, because this way you can see how to apply calculus to real life, how it's used in engineering. Question number 3. To determine whether the spectators are in danger in this scenario, find the x-coordinate of the point where the tangent line crosses y is equal 2.8. Because where is our y is equal to 2.8? Okay, let me, I can draw it here so it make it easy. So I'm going approximately, forgive me. So assuming this is negative 1.9, so this was a little bit above 2, but 2.8 is somewhere here. So we need to know if it's crossing, so at minute it crossed this y is equal 2.8, it's going to be under danger. Is this point safely to the right of the grandstand, or are the spectators in danger? So let's figure it out. So first of all, to determine whether the spectators are in danger in this scenario, we need to find the x-coordinate of the point where the tangent line crosses this y is equal to 2.8, right? Because 1.9 is matching here 2.1 or 2, tiny bit above 2. So we need to find out the coordinate for 2.8, coordinate of x, that's matching 2.8. All right? So that's our subject of interest. Y is equal 2.8, okay? And from the previous one, we found out that negative 2 and 2, safe for the slope is equal 1. Our tangent line is going to be y is equal x plus 4 for the point negative 2 and 2. So I'm using that tangent line, not tangent line, that graph, y is equal x plus 4. And I'm plugging 2.8 to find out which value of x will match, okay, and it's equal, x is equal negative 1.2. So which is going to be, it's right here, 1.2, somewhere here, right? I'm going to use this color. So assuming this is negative 1.2, okay? So this point is safely to the right of on the grandstand, okay? Which means x negative 1.2 and 2.8, right? Safe point to turn to the right. To turn to the right. Okay, so you have to pass a little bit and come here and then only turn. You don't want to turn right here, okay? because at this line your tangent line is 0, so you are reaching here and then start turning down, turning to the right. All right, question number 4. What if a driver loses control earlier than physicists project? Suppose the driver loses control at the point negative 2.5 and 0.625. So let's see where it is. Negative 2.5, it's somewhere here. And how much? 0. So 2 point, okay, this is not a 2 points, it has to be much further. Let's come look here, you can see better. Yeah, 2.5 and 0.65. Oh, it's turning from here. This is crazy. Okay, trying to cut the chase is turned there. Well, definitely it's crazy, but I guess they're just all they want us to show if it's safe or not. So what's we gonna do? So it says asking what's the slope of the tangent line is supposed to be off. Yeah, that's a mistake, of the tangent line. Okay, so we have f of x is equal 3x, x cubed plus 3x squared. They could get better coordinates, but that's okay. At least we can see where the danger is. Okay, and we get f prime, okay, because we need to find out slope, so we get derivative 3x squared, and I already explained why we'll take derivative versus rate of change. There is a difference between them. The rate of change is average of the velocity, and the derivative is a instant change at a given time. Okay, 3x squared plus 6x and plus 1. Okay, so we get f of negative 2.5. It's going to be equal 3 times negative 2.5. It's going to be minus 15 and plus 1. So this is going to be equal 18.75 minus 15 plus 1, and we have 4.75. So derivative of negative 2.5, let me put here also derivative, is equal 4.75. Okay, so what's the slope? We already found the slope. So question number 5, if a driver loses control in described part 4, let me change this, I'll do this. Scratch, okay. In described part 4, if a driver loses control in part 4, are spectators safe? Okay, so we have y is equal, it's moving by a road that mathematical model is mx plus b, yes? So 0.625 is equal 4.775, that's our slope, right? It's gonna 4.75 times, how much was the point? Negative 2.5. 2.5 and plus B. So it's going to be equal 0.625 equal negative 11.875 plus B. B is equal 12.5, okay? And Y from here is equal 4.75x plus 12.5. Okay, let's find out the value of x from here. So my y is 2.8. Where from we get 2.8? Remember? Right here, because that's the point that we are interested if it's going to be under danger or not. It's going to be 2.8. Where is it? 2.8 is equal 4.75x plus 12.5, right? And from here, 9.7, if I move, it's going to be negative 9.7 equal 4.75x, and x is equal negative 2.04. So under this scenario, the spectators are not going to be the same. Why? Because when y is equal to 2.8, right, x is going to be equal negative 2.04 comma 2.8. The x coordinate of the tangent line is approximately negative 2.04, and car traveling on that path would hit the grandstand. Why? 2.04. It's right here, right? It's coming right here. 2.04. And it's falling 2.04. It's gonna hit here. It's 2.8. So here it is. It's gonna hit the curb, and it's not gonna be safe. All right. So this is the point that we calculated, and we decided that it's a safe. So behind of that is negative 2.04. It's way far away. So it is not going to be the same. Okay, so we solved these problems. I hope it was helpful. It was interesting. Thank you for watching. Obviously, if you have questions, oh, there is a question number 6. So should you proceed with the current design for the grandstand, or should the grandstand be moved? Well, obviously it's gonna be moved, correct? Okay, so this is what I think. They should move the current design for the grandstand, because the spectators of the grandstand would get hurt if driver loses control at the point of negative 2.04 and 2.8, right? So which it is, which is the point that is behind of negative 1.9 and 2.8. Negative 1.9, 2.8 is the point. It's located at the front corner of the grandstand, right? So if it goes beyond, it's gonna hit the curb. So which means the design of this grandstand is an absolute disaster for the spectators. Now I'm really done. Okie dokie. See you later, alligators.